Hello everyone and welcome to the C++ 3D game tutorial series, a tutorial series in which we will create a 3D game in C++ and DirectX from scratch. In this first episode, we will see how to create the window in which we will render the 3D objects that will compose our game world. In each episode of this series, we will face three main parts: the requirements, design, and implementation of our 3D game. Let's start with the requirements. We need a C++ IDE. In this series, we will use Visual Studio 2022 Community. However, any other C++ IDE could work as well, even though Visual Studio is strongly recommended. The target platform is Windows. The target graphics API is DirectX 11. And last but not least, a good understanding of the C++ programming language is recommended. Now we can start the design part, where we will determine which classes to implement and how to organize them into appropriate software modules. To face this part, let's start by answering a key question. What problem are we trying to solve? In this first episode, our goal is to create a window where we will render our 3D game. So we have quickly identified the window class. But is the window class enough? What we need is a further class that manages the window itself and other future components of our game, like the DirectX graphics engine and so on. Let's call this class game. Also, the game class should provide a very important function called run that will contains a while loop. This particular loop is commonly called game loop and should keep the game running as long as the window remains open. Once the window is closed, the game should terminate. At this point, these first classes can be grouped together to create the most important and core software module of our game, that is the DX3D game engine, that stands for DirectX 3D, in which the game class will be its entry point. Last but not least, we also need the base class, a core class that will serve as the foundation for all the other classes in our engine. Let's make all the classes inherit from this base class. Let's also add an additional module called game, where we will place all the software components of our 3D game. If you have any questions, doubts, or comments about this topic, feel free to leave them in the comment section of this video or on our Discord server. You can find the link to the Discord server in the video description. Also, if you find these tutorials helpful, please consider supporting their development on Patreon. Every contribution makes the difference, no matter the amount. Great, we have gathered all the necessary information to start the implementation. As first thing, let's download Visual Studio installer for the following link. Once the installer is downloaded, let's open it. The next step is to select the desktop development with C++ workload. This is essential for developing our game in C++. At this point, we can finally download and install Visual Studio 2022 by clicking on Install while downloading button. Once the installation process has finished, we can finally open Visual Studio. On the welcome screen, let's click on the Create a New Project button. Now we need to select the empty project template. Once that's done, we can type the name of our project. Let's call it DirectX Game. In the next step, we can choose our preferred location to save the project. Last but not least, be sure to check the option Place Solution and Project in the same directory to keep all the project files organized in one place. Now we can go ahead and create our project. As first thing, let's enable the Show All Files option, which will allow us to manage files directly from the Solution Explorer window. Next, we need to select the platform for which we want to compile our program. Let's select the x64-bit platform option in the toolbar. Great! Now let's move on and create our first software module by adding the game folder. Next, we need to create the main C++ file. As we saw in the introduction, the game module doesn't contain any classes at the moment, but it does include the entry point of our program, the main function. The main function returns an integer value, in this case 0, to indicate the status of the program when it finishes executing. So far so good. For the next step, let's go to the project properties. Here, let's modify the output directory and call it bin. Next, let's change the intermediate directory and call it intermediate. With that done, we can finally change the C++ language standard to C++20. Last but not least, let's go to the C++ tab and find the multiprocessor compilation field. Let's set it to yes in order to quickly compile our program by exploiting all the cores of our processor. Great! With everything in place, we can finally compile and execute our program. Let's click on the local Windows debugger button in the toolbar. A console window should appear telling us that the program has terminated with exit code 0. Alright, we are now ready to dive into the debugging session. Let's place a breakpoint at the return 0 line by clicking on the left margin. Now, let's click the local Windows debugger button again. What's happening now? The execution of our program has paused at the red dot we just placed. At this point, we can step through the code, moving through the program one line at a time to observe how it executes. If we now press F10, the debugger will execute the current line of code and then pause on the next line in the same function. This feature is called step over. If we press F10 again, we execute the last line of code and the program terminates. What's next? We need to create the folder for the next module, the DX3D engine. Let's also add the include and source folders. In each of these folders, let's add a DX3D folder. This way of organizing the folders will allow us to easily include our header files throughout the codebase. At this point, we can add the first module of our engine, the core module. In this module, we will place all the essential and core files of our engine. Let's create the base class. Luckily, Visual Studio provides a useful feature that automatically generates the files of a class for us. Once that's done, we need to place the various files of the base class in their corresponding folders. The header file should go in the include folder, while the C++ file should be placed inside the source folder. In this case, the include folder will contain the public API that will be provided to the users of our engine, while the source folder will contain the private source code files that will not be accessible externally. At this point, let's start implementing our base class. The first thing we need to do is to add the base class to the namespace of our engine. Let's call it the X3D. A namespace is a container that allows us to group related code, such as classes, functions, and variables, under a common name. Next, let's add the constructor and destructor of our class. The constructor is the method called when an instance of our class is created, while the destructor is the method called when an instance of our class is destroyed or deallocated. In particular, we are defining a virtual distractor that is a special type of distractor that ensures proper deallocation of a derived class when it is deleted via base class pointer. Let's implement our first two methods. Luckily, Visual Studio allows us to automatically implement the methods starting from their signatures. All we have to do is select the method signatures we want to implement. Right-click the selected text, click on Quick Actions and Refactorings, and finally select Create Declaration Definition. The implementation of our methods will be available in the corresponding C++ file, in this case base C++ file. What's next? We need to fix the include header file. To do that, let's go to the project properties. Then click on VC++ directories and search for include directories field. At this point, we need to add two relative paths to the include and source folders. The paths are relative to the project folder, so let's add the x3d include and the x3d source folder paths. Now we can take advantage of the way we have organized the folders. We can easily include our header files by writing the x3d, core, and base header file. Alright, let's dive into the next step, the implementation of our window. First, let's add the window folders. At this point, we can create the window class. As usual, let's include the class inside the dx3d namespace. So, what do we need to do now? We need to extend our window class from the base class. By doing this, we will inherit the methods and attributes of the base class. Let's also add the constructor and destructor. Pay attention here. Be sure to add the override keyword after the destructor. In this way, the compiler is able to catch mismatches in function signatures during compilation, ensuring the correct function is being overridden. Cool, let's implement our methods. Before we proceed, since we are going to create the window using the Win32 API, let's add a new folder called Win32 and move the Window C++ file inside it. Finally, let's rename the file to Win32 window. So far so good. Now let's start to implement the window class. At this point, let's include the Windows header file, which contains all the Win32 functions we need to create our window. We are now ready to call the most important function of this class, the create window x Win32 function. As the name suggests, this function allows us to create a window by passing some specific parameters. The first one is the extended window style. Let's set it to null. Then we need to specify the name of a window class. A window class is a data structure that defines the main properties of a window. To create a window class, we need to call the register class X function. In particular, it needs a pointer of a data structure called WND class X. Let's create it. Here, we have initialized the WC variable with curly braces. This way of initializing a variable is called brace initialization and allows us to initialize the attributes of the WND class X structure to their default values. At this point, let's define the size. We also need to define the class name. Be sure to write L in front of the string. Finally, let's define the window procedure. We'll dive deeper into the window procedure topic shortly, but for now, let's pass the so-called default window procedure function. Last but not least, let's store the return value of the register class X function, which is the unique identifier of the window class, in the window class ID variable. With that completed, we can move forward with our create window X function. Let's pass the window class we just created using the makeIntAtom macro. Now we can set the title of our window. The next parameter we need to pass is the window style. In this case, we will pass a combination of various styles. We can combine multiple styles using the bitwise OR operator, which is the pipe character. In this case, we are asking the function to create a standard window by using the WS overlapped value, which includes a title bar with WS caption and a system menu with WS sysmenu. Next, we need to set the position of the window. Since we don't want to provide a fixed position, let's let the operating system choose the initial position for us by using the CW value. Now we need to define the width and height of our window. Unfortunately, the size passed in this way includes all the window decorations. To compute the correct size, we have to use the adjust window rect function. Great! Once adjust window rect has been executed, the final result will be available in the RC variable. The final width will be the difference between the right and left. The final height, instead, will be the difference between the bottom and top. We can safely set the last four parameters to null. We are now ready to store the handle of the window. Let's go to the window header file and add a void pointer attribute called handle. We use a void pointer here because we don't want to expose platform-specific definitions like those of the Win32 API in the public header files of our engine. What's next? We should check if the return values are valid. Let's start with the window class ID. If the ID is 0, something has gone wrong. Since the window creation will fail without the window class, we should throw an exception. An exception in C++ is a mechanism used to handle errors or exceptional conditions during runtime. Throwing an exception means the program jumps to a special block of code called try-catch block, designed to handle the exceptions. For now, let's throw a standard exception provided by C++ called runtime error. A very useful feature of this exception is that we can provide a descriptive message of the error that occurred. In this case, we can say that the register class X call has failed. Of course, let's do the same thing for the handle of our window. Alright, let's finally show the window through the showWindow function. Since we are using a void pointer, we need to cast the attribute to the HWND type. Let's use the static cast keyword. In conclusion, in the destructor, we should destroy the window instance. Let's do this by calling the destroyWindow function. As we can notice, we have implemented the initialization code of our window inside the constructor and the release code of the window in the destructor. This way to implement the code follow the C++ programming idiom called RAII, or Resource Acquisition is Initialization. The idea behind the RAII is that resources are acquired during object initialization and released during object destruction. This idiom would be particularly useful when we will use smart pointers later in the tutorial. Great! We have finished implementing the creation of our window using the Win32 API. With that completed, we can now dive into the creation of the game module. Let's create the game class. As usual, let's define the constructor and destructor. At this point, we can finally define the run method, in which we will implement the core of our game, the game loop. Pay attention here. We are defining the run method as final. The final keyword is used to indicate that the run method cannot be further overridden or inherited. It prevents unintended extensions or overrides in the right classes. Let's go ahead and implement our methods. For the next step, we need to separate the standard code from the platform-specific code. In the run method, we need to use Win32 functions. So let's add a Win32 folder and create a new C++ file called Win32 game. At this point, let's cut and paste the run method from game C++ file to Win32 game C++ file. Good, let's dive into the implementation of the game loop. Let's add a while loop. In this case, with true as the condition, we have created an infinite loop. However, we want to exit from this loop at some point. To do that, let's go to the game header file and add a boolean flag called isRunning. Let's initialize it as true. Now, if we replace the true value with the isRunning flag, the loop will terminate as soon as the flag is set to false. At this point, we need to process the various messages generated by our window. A message is generated every time we perform an operation on the window, such as clicking the close button, moving the window, resizing it, and so on. If we don't process these messages, none of these operations can be performed. To process these messages, we need to call a Win32 function called peakMessage. Each time peakMessage is called, it checks a special message queue for a posted message. By passing pmRemove value as parameter, we are asking the function to remove the next message from the queue. Also, if there is at least one message in the queue, the function returns true. Therefore, by placing the peakMessage function as condition of a while loop, we will process all the messages inside the queue. Once the queue will be empty, the loop will terminate. At each iteration of the loop, we have to process the message just retrieved. In this case, we use translate message and dispatch message to translate and dispatch the message to the window procedure defined for our window. For now, it is the default window procedure. We will discuss how to define a custom window procedure in a moment. The last thing we need to do is to call sleep. This function suspends the execution of our program for a specified time, in this case 1 millisecond. We do this to prevent unnecessary CPU usage. Great, we are now ready to instantiate our window. Let's go to the game header file and add a window pointer attribute. At this point, the window class is not defined. It would be natural to include a window header file to provide the definition. However, including header files in other header files can lead to serious issues like circular dependencies. To avoid these problems, let's create a core header file. Here, we will create a forward declaration for the various classes we have just created, including window. Forward declarations are used to declare the existence of a class, function, or variable without providing its full definition. At this point, if we include the core header file in the game header file, we declare the existence of the window class without needing to provide its full definition, and we avoid problems like circular dependencies. Now we can finally define the display attribute. Next, we need to create the window in our game class. Let's create an instance of the window in the game constructor using new. At this point, we can safely include the window header file in the game C++ file. Make sure to delete the window instance in the game destructor. Note that this is an older way of handling instance creation in C++, where we manually delete the instance in the destructor. We will explore a better approach based on smart pointers in a few moments. With that done, let's move to the main C++ file where we can finally create a game instance. Before proceeding, we can create a convenience header file called all in the include.dx3d folder. As the name suggests, this header file will include all the useful classes and data structures of the engine, making it easier for the user to access and use them. Let's start by adding the game header file. In the end, let's create a game instance in the main function. Let's also place some breakpoints in the most critical points of our code. Of course, the first breakpoint we reach is in the game constructor, where we create the window instance. We have now reached the window constructor. Once register class X has been executed, thanks to the Visual Studio debugger, we can inspect the value of window class ID. We can see that the value is not 0, meaning the window class has been successfully registered. If we check the RC variable, we notice that the initial value is the one defined in the code. Now, if we proceed to execute the adjustWindowRed function, we can see that the size has changed to include the size of the title bar, borders, and other window decorations. Once createWindowX function has been executed, even the window handle variable is not null, so everything has gone well. Finally, when we execute the showWindow function, the window should appear on the screen. And here is our window. It works correctly and responds to our inputs, but if we close the window, the game doesn't terminate. This is because we are not currently handling the events of the window with a custom window procedure. So let's go to the Win32 Windows C++ file and finally create the window procedure. At this point, we need to add a switch statement to handle the message parameter. For the default case, we will return the defWindowProc function. To handle the close window event, let's add the WMClose case. So, what do we need to do when, for example, the close button of the window is pressed? We need to call a specific Win32 function called postQuitMessage. This function adds a WMQuitMessage to the message queue, signaling that there is a request to terminate the application. Last but not least, let's remember to pass the address of our custom window procedure function to the window class structure. What is left to do? We need to handle the quit message added to the queue, So let's go to the Win32 game C++ file, and in the run method, let's add a condition inside the while loop. If the message is W and quit, we should set the isRunning flag to false and exit the loop with a break. This way, we will exit the game loop and the program should terminate. Let's debug it. If we press the close button now, we can finally set the isRunning flag to false. This leads us to the game distractor, then the window distractor, and if we continue, the program terminates successfully. Cool, we have finally implemented our window. With that completed, we can go to the main C++ file and add what is called a try-catch block. In the try block, we place the code that could throw exceptions. In the catch block, we catch the exception that was thrown and we attempt to handle it. Of course, we have to include stdexcept to provide the runtime error definition. Let's go to the core header file and include it. In this case, if a runtime error is thrown, we will return an exit code called exit failure to signal that something has gone wrong. If everything has gone well and no exception has been caught, we can safely return the exit success value. We can also add other catch blocks, one for each type of exception. Runtime error is a specific exception. STD exception is a generic and abstract exception. At the end, as last resort, we can handle all the other exceptions not specified in the previous catch blocks by adding a catch block using the three dots as parameter. This block is called catch-all handler. Last but not least, we should pay attention to how we register the window class. As a first step, we can create a so-called lambda function called register window class function. A lambda function is a function without a name that can be defined in line within the body of a function, like the window constructor. It's a convenient way to define small throwaway functions for short-time use. Let's place the register class code inside it. Now, let's call the lambda function and store its return value in the window class ID variable. At this point, if another window is created and register class X is called two or more times for the same class, the function will fail and return 0. To avoid this issue, if we define window class ID as a static constant variable, register window class function on subsequent calls will not be executed again and the same class ID will be reused. What's next? We could instantiate and release our window inside game class with a different approach. Here we are using a row pointer, that is a simple pointer that contains the address to the instance of our window. In order to destroy this instance, we have to manually delete it with the delete function. However, let's imagine dealing with two or more attributes handled this way. The probability of forgetting to delete something in the destructor increases significantly, leading us to the memory leaks. Luckily for us, there is another approach based on the so-called smart pointers. In short, a smart pointer, specifically the unique pointer we are going to use, is an object that holds a pointer to a particular type of instance, in our case, a pointer to a window instance. When the destructor of the smart pointer is called, it automatically deletes the instance for us. At this point, we can create a unique pointer using the makeUnique method in the constructor. And we can remove delete display from the game destructor. Now, if we try to debug our code, we can see that during the game constructor, we create a unique pointer for the window, similar to what we did previously with new. But what happens if we close the window? We reach the window destructor, but we no longer manually delete the window instance in the game destructor. With the usage of smart pointers, we can now understand why it's so important to follow the RAII idiom. That's all, folks. Today we learned how to create a window using the Win32 API, along with the game and base classes. We also explored how to organize these components within our DX 3D game engine. In the next episode, we will see how to start to create the DirectX 11 graphics engine. I hope you enjoyed this video. See you soon. Thanks for watching.